So today we're talking about parallelograms, and specifically we're talking about their properties and their conditions. So a property is something that's always true about a shape. You might call a property a characteristic. For example, here's a property of my house. It has 3 bedrooms. That's a characteristic of my house. It tells you something about what my house is like. Conditions, on the other hand, let you tell whether an object belongs to a particular group. So you could use a condition to tell if a shape is a rectangle. Another word for a condition might be qualification. It's something that says, oh yes, this shape qualifies as a rectangle. I can accurately say it is a rectangle. So for example, the house is located at 2624 Winter Street. So that's a qualification for being my house. That's my address. So if the house is at the address, then that's my house. That's a qualification for being my house. Any house could have 3 bedrooms. Not all the 3-bedroom houses in the world belong to me, but the one at 2624 Winter Street does. That's why this is a condition, and the fact that it has 3 bedrooms is a property. One piece of information describes my house, and the other is a qualification for being my house. It says this is the house that belongs to me. So now that you know the difference between a property and a condition, let's look at the properties of parallelograms. So here are some properties of parallelograms. These are true about any parallelogram. First of all, there's our definition. It has 2 pairs of parallel sides. So the top side is parallel to the bottom side, and the right side is parallel to the left side. That's the definition. Next, I want to look at this property that says the diagonals bisect each other. So I've added some diagonals to my parallelogram here, and bisect, what that means is cut in half. So the diagonals are going to cut each other in half. I'm going to show that by putting tick marks on them that says each half is equal. So this half is equal to that half, and this half is equal to that half. The diagonals are bisecting each other. Our next property says the consecutive angles are supplementary. Well, my first parallelogram is getting a little bit busy, so let me start a new parallelogram over here. And consecutive angles are kind of like next door angles, so that would be like this pair right here. And supplementary means they add to 180 degrees. And that's true over on the other side as well. So this pair also adds to 180 degrees, as does the top pair and the bottom pair. Our next property tells us that the opposite sides are congruent, so they have the same length, and I'm going to denote that with tick marks. So these have the same length and these have the same length. And then this last property says that opposite angles are congruent. And we actually already showed this before, didn't we, when we talked about supplementary consecutive angles. But the opposite angles are going to have the same measure. So we just have 4 properties that we looked at right there. Now we're going to use those properties to solve some problems. So first of all, we're given some information here about parallelogram JKLM. We're told that LM is 86 millimeters, so let's label that on here. Here, LM is 86. And then LK is 100, so we're labeling that as well. And then the measure of angle JLM is 42. So not JLM, JML. JML is right there, and then that's 42 degrees. So that's the information we've been given. Let's think about what we know based on that. Well, we know that opposite angles are congruent, which means that this one, JKL, is also 42 degrees. We know that opposite sides are congruent. So JM is 100 since it's opposite of LK, and JK is 86 since it's opposite of ML. We could also figure out the other angles. Since consecutive angles are supplementary, we can subtract 42 from 180 to figure out our missing angles. It looks like the remaining angles are going to be 138 degrees, so let me label those. Okay, that's pretty good. So now we really just need to look at these questions and see if we know the answers. I'm going to pause the video and you fill out all the information that you can for 1, 2, 3, 4, 5. I think you got this. Pause it and hit play when you're ready to see the answers. And there they are, all information that we pulled straight off of our labeled diagram. So on this next set of problems here, we're going to use the property that says that the diagonals bisect each other. So what that means is that the left half is equal to the right half, and the top half is equal to the bottom half. And we can use that to write 2 equations. Great, so we've used the angle bisector property to write a couple of equations here. Now let's solve the equations to find the values of x and y. Great, so now that we know x and y, we can just substitute those into our expressions to see the value of each piece of the diagonals. So we can see that both BE and DE are equal to 18, and AE and CE are both 12. So then BD would be 36, and AC would be 24. So we just used those 4 properties of parallelograms to figure out a lot about the two that we were given. So we talked about properties of parallelograms, characteristics that describe what parallelograms are like. Now let's talk about conditions for parallelograms. If these things are true about a shape, that means we know that shape is a parallelogram. So these are the facts that allow us to conclude that a shape is indeed a parallelogram. And here's just a few. So if a quadrilateral has one pair of opposite sides that are both parallel and congruent, that quadrilateral is a parallelogram. So that would look like this. In this example, my opposite sides here are congruent and they are parallel. If that's true, I know my shape is a parallelogram. Let's look at the next condition. It says that if a quadrilateral has 2 pairs of opposite sides that are congruent, then it's a parallelogram. So in other words, if the top is congruent to the bottom and the left is congruent to the right, it's a parallelogram. So if a quadrilateral has 2 pairs of opposite angles that are congruent, then that quadrilateral is a parallelogram. So if these angles are congruent and those angles are congruent, then it's a parallelogram. Next, if a quadrilateral has any angle that's supplementary to both of its consecutive angles, then it's a parallelogram. Let me draw that one. So for this one, the picture makes a big difference. First, I'm going to take a look at an angle. Let's look at this angle right here. Now, what this condition says is if that angle is supplementary to both of its consecutive angles, this is a parallelogram. So that means that this bottom one and the top one add up to 180. And also the bottom left and the bottom right add up to 180. That's what it means for an angle to be supplementary to both of its consecutive angles. It means when you add the measures of the angles right next to that one to it, they add up to 180. And there's one more condition here. It says a quadrilateral that has diagonals that bisect each other is a parallelogram. And this is also one of the properties we discussed. So the left half of the diagonal is equal to the right half for both of the diagonals. The diagonals cut each other in half. If that happens, your quadrilateral is a parallelogram. So there's 5 conditions right there. And here's 5 examples that we want to look at. So what we want to do here is determine whether or not we can conclude that these quadrilaterals are parallelograms. Are they or are they not? Do we know? Think about it and then write down why or why not. Why don't you take a look at the first one here, pause the video for a second, write your answer, and then hit play when you're ready to see the correct answer. So this one is a parallelogram, and it's because of our green property up top that says that 2 pairs of opposite angles are congruent. This next one is not a parallelogram because the opposite sides are not congruent. That was the second condition we looked at. Number 3 is a parallelogram because the diagonals bisect each other. That's our 5th condition. And number 4 is a parallelogram because there's one pair of opposite sides that are both parallel and congruent. And that was the very first condition that we had there. And this 5th one is a parallelogram because it has 2 pairs of opposite sides that are congruent. That was our second condition. So you can see you can use conditions for parallelograms to determine whether a given diagram, a given shape is a parallelogram or not.